Okay, in this one we're going to see how you can manipulate regular expressions in C or regex with the standard library. So the first, first thing first, maybe if you don't know what regular expressions are, it's just a domain-specific language. So a very small language that is made especially to match on strings. So if you have a string like A, B, C, and then a bunch of C at the end, you want to say, I want to find in a string if there is an A, then a B, then 0 or more C's or something like this. And in regular expression fashion, you would do like A, B, then C, then a star. That means like you can have 0 or more C character after the end. And of course, it gets much more complex than this, but for now, this is not a video about regular expressions themselves, but how you can execute them in C more. So let's do that. So you will need to import the regex.h header. And here are the functions we will use in this tutorial. So there is a regular regcomp, regexec, and then there is a regfree, which you can probably guess. Since it's going to allocate some memory, we need to free it at some point. And there is regerror, which is similar to p error or stuff like that, where it gives you an error message that is human readable if there is an error. And so regular expression comp will compile your regular expression and exec will execute it. So yeah, let's show you a basic example. So I have pre-written some stuff. And so here you can see that you need to allocate a preg or a regex underscore t struct, which will hold the compiled regular expression. And so you can see that it is used as a first argument. You just give a pointer to where you want your regex to be compiled. Then you give the string to the compiled regex. And then there is a number of flags, which I will detail later. And this function returns something else than 0 if it fails. It returns an error code. Next, you have regexec, where again you just give a pointer to where the regular expression is stored. Then you give it the string you want to match onto, and the next parameter we will detail later. The last one is again the flags, but those ones are a bit specific and we won't cover them here, but you can read up the manual if you're curious. And so the result is 0 if there is a match, and it returns reg no match if there is no match. And at the end, of course, we free the regular expression. So let's see this in action. And so here you can see that I have the regular expression that matches one character A and then 0 or more character B. And then I have A, B, B, which should match. So let's see it in action, and indeed it matches. But now if I put 0B, it should still match. But if I put like C and then a bunch of B, now it won't match. So yeah, about what you would expect. And so yeah, there is a few flags on the regcomp function that you will probably want to use. So by default, the regex library uses the old POSIX regular expression notation. So for example, if you want groups, you have to have a backslash before the parenthesis, which is quite strange. Or for example, you might be accustomed to, so there is this for the little star for 0 or more, but there is also the plus in most regex, which means 1 or more. But this plus does not exist by default in the standard of regular expression that it is used by this. But if you want, you have the flag here called reg extended, which is a newer standard of a regular expression, which is about what you expect. So plus exists, or the parentheses are just regular parentheses, no need for a backslash before them. And so here I can demonstrate maybe, I mean, of course this will fail, but if I put A here, this should match. And if I put 0B, it won't match. Another one that can be quite useful is reg icase, which will ignore the case of the letters. And if you want multiple flags, you can OR them. It's like bitwise flags. So let's keep the extended actually. So I can have my plus, and so here if we have this, but if I change the case of a letter, it will still match. But if I don't have the I case, it won't match, like so. Alright, next we will cover matching groups. So you can have, of course, groups like so in your regular expression, then a second group. And now you want to get the string that was matched, but for those group, not for the whole string. So I have another example for this. Let me copy paste it here, remove the other stuff because it's a bit confusing. So still, just like before, we have a regcomp with this time two groups. So I have an A, then any number of B, then a C, and then any number of D. Let me make that a bit slightly bigger. So the matches will be stored in a regmatch array. And so the regmatch structure just hold the indices to the first character of the group that was matched and to the character just after the last one. So it's an exclusive range. I will just run the example and it will make it clearer. But so here we have an array of potential match groups, which we are going to pass to regexec. So those were the arguments that I told you to ignore before. So first, you still give it the regular expression compile, you give it the string to match on, then you give it the number of match group that we can store. In my case, it's 10, and then you give it the array where you want to store the beginning and the end of the matching groups. And so again, if the result is 0, that means there is a match. And so that's basically the same code as before, except that here I do a for loop where I iterate on every single one of the groups to show what's the group start and what substring it matched. So yeah, let's just run it. So in this case, there is no match because I just didn't save the file. Okay, so you can see that by always, so in your p match 0, so the first element will always be the whole match. So everything, ignoring completely the regex group, it will just be the whole regular expression, what was the start and end of the match. And then just the first indices will be, the second element of it will be the first group, and the third element of it will be the second group. And so, and every single other match, so if you have like, here we have capacity for 10 of them, but of course there is only 2 groups. The rest of the array will be set, the start and end will be set to -1. So here where you can see that I start at 0, I go until I find one that is set to -1, or I reach the end of the array. And so the attributes of the regmatch struct are rmso, which is the start, and rmeo, which is the end. And here I create a buffer where I copy the substring that is a match, and I just print the start and index, and also the string, the substring that was matched. And here in our little example on the right, you can see that I have a string A, B, B, then C, then a bunch of D, where the first match is of course the entire match, so just the original string. If I put like some extra character that are not parts of the thing, it should, you see that it ignored the pound. Not the pound, but yeah, the hashtag characters before and after, so it's just the match of the whole regular expression. Then the second one starts at 2, but ends at 5, and so it's our first group. And the third one starts at 5, ends at 11, and that's the second group. And that's how you can get regular expression groups in C. Lastly, I will just quickly show an example of how you can use the regerror function to get clean error messages, because here you can see that, for example, if I add a parenthesis, or Yeah, maybe, okay, it shows a parenthesis character. Let's try to make it fail. Okay, I cannot make it fail. This is a... I thought that would fail. Okay, so here I have just an assertion fail because it's different than 0. But you can get a cleaner error messages with regerror. Let me remove that, copy paste my other example. Yeah, maybe let me just forgot to p-reg like so. Let me just make one that will fail quickly, and again that's p-reg here, and the regex is I think the regex is ap this. Okay, so here we compile a regular expression which is invalid, and it returns an error code. If this error code is different than 0, you then need to allocate a character buffer where the error messages will be stored. And you need to specify the size of this buffer so that you don't have a buffer overflow. And then to the regerror, it's rather simple. You give it the error code, the compiled regular expression, the error buffer and the size of this buffer, and then it will just put in the error buffer a human readable string that indicates why it failed. So in this example, you can see that it printed regex error, this regex invalid preceding regular expression, which is a bit clearer than just an assertion error. So yeah, that's about it. And yeah, maybe lastly, to end the video, I will show an example of how I use this in one of my side projects where I rewrite the sed command. Doesn't matter much if you don't know how the sed command works, but I would just like to show you. So I have, for example, in this parse.c, I have a little wrapper x regcomp, which just handles errors a bit nicely. But here you can see that there is, for example, addresses in sed that can be a regular expression. And here I just do a regular regcomp on it to compile the regular expression when I parse the language of sed. Then in later, when I need to execute the sed script, I use regexec, where I again have the p-match and the number of match that I can store as a maximum amount of match. And you can see later that every time you can do replacement on specific groups. So it's like a set can do like search and replace. And here I use like the p-match struct to get the individual groups and then copy them into whatever string I need to modify. So yeah, that's the small example that I will link in the description if you want to take a deeper look at it. But yeah, that's about it. That's how you do regular expressions in C. I hope this was useful, and I'll see you in the next one.